Jai Hind, welcome to class of Fundamentals of Electronics Engineering. We will be taking up the topic Communication Engineering for today. So, these are the contents of this unit. We'll be talking about fundamentals of communication engineering, basics of signals, representation and analysis. We'll be talking about electromagnetic spectrum, then elements of communication system that will include the block diagram. Then what is the need of modulation in communication, how we do modulation, how demodulation is performed, and after that this unit contains these topics as well, data communications as well as wireless communication. So before starting with the actual communication system where we'll be talking about modulation and demodulation, we need to understand our electromagnetic spectrum. What are electromagnetic waves, what is communication, how EM waves are transmitted and used for communication, right? So our electromagnetic waves can be thought as a stream of particles. So they're not just wave, they are wave and particle both, where each particle is moving with the speed of light. Now as they are moving with the velocity of light, they are considered as waves. Now each particle contains a bundle of energy and this energy is called as photon. So the radio waves are my electromagnetic waves which have the longest wavelength in the EM spectrum. Now radio waves are generated and propagated by radio transmitters. These waves are then received by radio receivers. And how do these receivers work? They are tuned at particular frequency and they receive that particular frequency only, which converts these into mechanical waves played through radios and other devices. Now, due to their wide range, they are primarily used in communication systems like broadcasting, communication satellites, computer, networking systems, radar, and other kind of navigation. So these have plenty of applications. If we see the electromagnetic spectrum and we want to see what are the various waves included in this, how their wavelength and frequency vary, this picture depicts is that. So this is electromagnetic spectrum according to the energy of photon, right? So here we can see it varies from radio waves to gamma rays, where we can see that wavelength is decreasing, whereas in this direction frequency is increasing, right? So if we start from radio, then microwaves, then infrared, then visible, then ultraviolet, then X-ray, and then gamma rays, right? So after radio waves, we can see how the wavelength is decreasing, right? And in this direction, moving from radio waves to gamma rays, our frequency is increasing, right? So increasing, decreasing the time period of the waveform, we can show the same. So this is our electromagnetic spectrum. If we actually want to see the frequency range for various waves, like extremely low frequency, then low frequency, then medium, and then high frequency, how these are classified on the basis of frequency content of them. So we can see that 30 to 300 hertz, it is extremely low frequency, and the typical application is power line communication. If you talk about very low frequency, the frequency varies from 3 to 30 kilohertz and used for submarine communication. If you talk about extremely high frequency, this varies from, its frequency range varies from 30 to 300 gigahertz, and these are basically used for satellite communication. So here we can see for such important application these are used, like AM broadcasting we use medium frequency, landline telephony we use high frequency, from FM broadcasting and TV we use very high and ultra high frequency, and for satellite communication, as I earlier said, it's extremely high frequency. Right? So this was the prerequisite. We need to understand about signals and what are the frequencies that are used for communication. Now, what is communication? The communication can be defined as actual exchange of information between a transmitter and receiver. So the purpose of communication system is to transmit message of intelligence from a source to user. This communication may be defined as a process of establishing connection or link between 2 points for information exchange. Now, if we talk about communication equipments, then the electronic equipments used for communication purposes are called as communication equipment, and this complete system comprising of the electronic equipments, the transmitter, receiver, the signal itself, the whole system is called as communication system. If I want to classify communication system, there could be several ways of several bases for classification. If I talk about if I classify my communication equipments on the basis of type of equipments, then we do have simplex, half duplex, full duplex, right? So on the basis of equipments, we have what is simplex. It can either do either transmit or receive, right? If we talk about duplex, a duplex is a kind of equipment that can transmit as well as receive, but only one thing at a time. So walkie-talkie is the simple example for that. For simplex, if it is a transmitting device, keyboard as a transmitter, like monitor is a display device, that is an output device, right? So half duplex example is your walkie-talkie. You can talk and listen both the things, but only one at a time. Now, if you talk about full duplex systems, your full duplex systems include your transmission and reception simultaneously. So modern mobile phones are example of your full duplex system, right? So after, on the basis of communication equipments, if we classify your communication system on the basis of frequency, then we have passband, right? Passband or bandpass, and we have baseband. Now, what is my baseband communication? This baseband. Sorry. Baseband communication. Communicating at low frequency. Like if you would be sitting in front of me and I'm communicating to you using my audio signals only, and you're not using any equipment to hear me, and I'm not using any equipment to transmit my signal, then that kind of communication would be called as baseband communication. What is passband or bandpass communication? In my bandpass or passband communication, the signal is made to travel after applying modulation, that is frequency shifting. That is, a low frequency signal is shifted to high frequency level and then it is communicated. Excuse me. So on the basis of frequency, we can classify it as baseband and passband. If I classify it on the basis of message signal, that what kind of message signal I am actually transmitting. So that depends on either I'm transmitting analog kind of signal or digital kind of signal. Now, what is analog communication? Here my message signal would be purely analog in nature, that is continuous function of time. Continuous function of time, right? And if I talk about digital communication, then the message signal that I am transmitting would be in the binary format. Let the initial input message be analog, but if I am converting it into digital form first, then communicating it, then that kind of communication system will be called as digital communication system. Because we know most of the signals available in nature are analog in form, but if we are using digital mode of communication for them, then there is a need for conversion of signal from analog to digital form, right? Then that kind of communication will be called as digital communication. What are elements of a communication system? Here we'll basically be studying about the basic block diagrams of a communication system. So communication means sending, receiving and processing of information between two or more devices. So if we talk about the collection of elements which works together to establish a communication between the sender and receiver is called a communication system, true, as discussed earlier. Some examples of communication system include your radio broadcasting. This is an example. Radio broadcasting, this is a complete system, right? In television broadcasting, radio telegraphy, mobile communication, computer communication. These are examples of a complete communication system. And if we want to study the basic blocks within it, that will be the next slide, right? Two or more people communicating with each other by using sound signals is known as communication system. So this is the block diagram of communication system. This must be including all the elements of a communication system, right? So if I talk about the basic components of a communication system, this would include your information source that should be generating your actual message. Now your message could be your audio signal, right? This could be your audio, like I'm talking right now. This could be your video. This could be text. This could be picture, right? Picture. So these are the basic kind of information or messages that are used for communication, right? So now the next thing is, when we have your message in these forms, the next thing is to convert it in the form that is desirable, right? I have to see how capable my system is. What is the mode of communication? What is my available channel? Is my available channel capable of transmitting audio signal as it is, or there is some need of conversion, right? If I want to transmit voice, but the channel available is a wire, wire cannot carry voice. Wire will carry a copper cable, will carry electrical pulses. So there is a need for conversion of my audio signal into electrical pulses. And when I convert that audio signal into electrical pulses, for that I would need a transducer. For that I would need a transducer. And after transducer, what is needed to be done is we pass it through a transmitter, and role of the transmitter is to match the characteristic of the input signal with the available channel. And if the available channel is capable of transmitting the signal as it is, it will pass on. Otherwise, in most of the cases, in passband communication or bandpass communication, the transmitter would perform the task of modulation. Transmitter will perform the task of multiplexing. Transmitter will perform the task of modulation. Transmitter will perform the task of multiplexing, right? Then after modulation and multiplexing, now the big question is, what is modulation and what is multiplexing? Modulation will simply do this frequency shifting. If you have audio signal that falls in the range of 20 to 20 kilohertz, that will be shifted to radio frequency range, which will be in your megahertz or gigahertz, right? So modulation, it is the process of altering the exact definition will not be relatable at this point of time. Still, I would say it is the technique of altering the characteristic of a high frequency carrier wave with respect to the instantaneous value of a message signal. It simply means we alter certain characteristics, makes it capable to travel long distance. That is modulation. This is basically frequency shifting. What is multiplexing? We enable a single channel to transmit a multiple number of message signals or input signals simultaneously. That is multiplexing. This is to increase the signal carrying capacity of a channel, and modulation is to make it capable of traveling long distance without increasing the antenna height up to too high, right? So these things are performed at transmitter. Next is the channel. Now channel could be your wired system or your wireless system. Noise is something that is inherent. Noise will definitely be incorporated in the channel, right? Noise will get mixed up in the channel. So there's a requirement to study about noise as well. Then after passing through the channel, it reaches your other end, the receiver. Electrical signal is received. Now again we need a output transducer that will convert back your signal from electrical form to audio form. because initial example I have considered audio signal. Output transducer then in the desirable form, which is your message, sound, light, picture, words, etc. It is provided to the destination. See, so we have whatever I have discussed just now, that has been elaborated in detail in these slides. Information source. This could be human speech, picture, words, plain text in some particular language, right? What is the role of input transducer? Converts one form of energy. It converts. The job of a transducer is to convert one form of energy into another. This is the basic definition of a transducer as well, right? Best example of an input transducer is the microphone. Microphone we all use while talking. That will convert your audio signal into electrical pulse, right, which is placed between the information source and the transmitter section. Microphone is a device that converts your voice signal into electrical signal, right? There's a message that you get when you want to access Google, some app that will ask to allow your microphone, so that when you speak, that can be processed further. Transmitter. The transmitter is a device which converts the signal produced by the source to a form that is suitable for transmission over a given channel or medium. Transmitters use a technique called modulation to convert the electrical signal into a form that is suitable for transmission over a given channel or medium. Now, modulation is the main function of a transmitter. So, whenever you're mentioning about transmitter, modulation is something which you cannot miss out. Whenever you're mentioning transmission, you have to mention modulation. The modulation increases the strength of the signal without changing the parameters of the original signal. Thus, the resulted signal overcomes the various effects which make it to become weak. The communication channel is a medium through which the signal travels. The communication channel is a wired or wireless medium through which the signal travels from source, that is transmitter, to the destination, which is your receiver, right? Two categories, wired and wireless, already discussed. If it is wired, copper cable, coaxial cable, optical fiber, these are the classification on the basis of wireless. These are further classified on the basis of the frequency range, right? Ground wave, sky wave, space wave, so on. Some examples of wired channels include coaxial cables, fiber optic cables, and twisted pair telephone lines. Examples of wireless channels are your air, water, and vacuum, right? Right, in the channel, the maximum attenuation does not occur at transmitter or receiver. The maximum attenuation occurs at in the channel. While your signal is propagating, maximum attenuation occurs here only. What is noise? Noise is an unwanted signal that enters the communication system via the communication channel. Is it desirable? No. Noise is not at all desirable. But why are we considering noise, and why are we studying about noise? Noise is something that we cannot avoid. It will somehow get mixed into a signal while your signal is propagating from a transmitter to receiver. That is within the channel. So, if you are a good engineer, you're designing a system, a communication system, you have to study noise. You have to, you should be knowing the information that what frequency you're communicating, what is the channel that you are using. Then you'll study about what kind of noises can affect your communication. Then after that, you actually calculate the signal strength that is to be transmitted, because there is some power requirement at the receiver. There is some power at the transmitter that you know about, that you're transmitting, right? Knowing the power requirement at receiver and having the knowledge about the power that you're transmitting, right? And then knowing the efficiency of the system. Here the efficiency will depend on noise. Now, if you're transmitting, if a system has 60% efficiency, then if you're transmitting 100 watt, what will you get at receiver? Just 60 watt, right? So, and how do you calculate that there is an attenuation of 40%? That you calculate only after knowing the kind of noises that affects your system, right? So, study of noise is important. So, noise signal degrades the transmitted signal. What is the receiver? Receiver is a device that receives the signal and from the channel and converts signal back to its original form. So, if modulation and multiplexing has occurred at transmitter, then at receiver, demodulation and demultiplexing will occur. Right? TV set is a good example of a receiver. TV set receives the signal sent by the TV transmitting sections and converts the signal into a form which is easily understandable by the human who are watching TV. Output transducer. The transducer that is present at the output side of the communication system is called output transducer. Generally, the output transducer converts the electrical signal into non-electrical signal. The best example of an output transducer is the loudspeaker, which is placed between the receiver section and the destination. The loudspeaker converts the electrical signals into sound signals which are easily understandable. So your output transducer, its job is to convert your signal back into the original form, which is understandable by the human destination. Like if initially your audio signal was converted into electrical signal, then again at receiver, your output transducer will, what it will do, it will convert back your electrical signal into your audio signal. Destination is the final stage in communication system. Generally, humans at some place are considered as the destination. Destination is a place where humans consume the information. For example, if you're watching TV, you are considered as the destination. Now, if I talk about what are the various losses in communication, this can be classified as attenuation, distortion, interference, and noise. What is attenuation? Reducing the signal strength. What is distortion? Change in the actual signal content or waveform or shape of the signal. What is interference? Addition of unwanted signal. That is again because of noise, right? And what is your noise? It is random and unpredictable electrical signals from internal or external environment. Even thunderstorms are example of noise. Eddy currents produced within the system is an example of noise, right? So these are kind of losses that we face in a communication system. Baseband and passband communication, this has been explained earlier when we classified communication system on the basis of frequency. So if we are communicating at a frequency without making any alterations in it, then this is called as baseband transmission. And if you are shifting the frequency and doing modulation, then that is called as passband or bandpass modulation or communication, where at the receiver the signal is shifted back to its original frequency. Now, if I want to classify my communication system, which can also be called as classification of modulation, it can be classified as analog and digital broadly, right? Here, modulation depicts communication. Communication system or modulation can be classified as analog and digital. If I want to classify, now what is analog modulation? Where my message signal is analog in nature. If my message is analog, analog modulation. If my message is digital, then that kind of modulation is called digital modulation. Analog modulation, we have amplitude modulation, frequency modulation, phase modulation. So, as my analog signal can be represented as x equals to a sine omega t. So, an analog signal have this characteristics, which is the amplitude, and this, which is the angle. So, omega is my 2 pi f. It has the complete angle, it has the frequency. So when I alter the amplitude of a signal, that kind of modulation is called as amplitude modulation. If you alter the angle of the signal, that includes its frequency as well as phase. These kind of modulation is called as angle modulation. This can collectively be called as angle modulation or frequency modulation and phase modulation. Now, if I talk about digital kind of modulation, we have ASK, amplitude shift key. Here my signal is binary, but my carrier is a high frequency sinusoid. If I alter the amplitude of my carrier with respect to message, that is amplitude shift keying. If I alter the frequency of the message, that will be called as frequency shift keying. If I alter the phase of my signal, that will be called as phase shift keying. We will be studying about the details of it in further lectures. So this is the broad tree that is classifying my communication system. Now, if I talk about what are the advantages of analog communication, your transmitter and receiver circuits are simple. It needs low bandwidth. Frequency division multiplexing. This is a kind of multiplexing which we'll study further. This can be used. This is a simple kind of multiplexing. If I talk about drawbacks, because we know that there are some advantages associated with your digital kind of communication or digital modulation. So we are talking about the limitations of analog and as well as we first get to know about the advantages and the disadvantages. If I talk about disadvantages, it's very noisy because your analog signal is a continuous function of time, and noise of any power or amplitude can corrupt the quality, right? So noise affects the signal quality. It is not possible to separate noise and signal. It is possible, but it is difficult to actually it is difficult to separate noise and the signal. There are repeaters required as the signal strength reduces, right? Coding is easily available and applicable on digital communication, not on analog. It is not suitable for transmission of secret information. True, because encryption and coding we can apply on digital kind of communication. There are plenty of applications, include we have mentioned few broad ones: radio broadcasting, TV broadcasting, and telephones, right? So this is about the complete communication system. What is communication system? What is communication? What are the various blocks of communication system? So prior to understanding this, we did study about what is electromagnetic wave. We did study about the electromagnetic spectrum, that it varies from X-ray like radio waves to gamma waves, how their frequency and wavelength varies, right? Why electromagnetic waves are used for communication, what are different applications. Then we understood the definition of communication. We did study about the various blocks of a communication system. Each block we have understood in detail, right? And then advantages and applications. So that's it for today. Thank you so much. These are the references I've used.